Hello students, welcome to Sarasa classes. Now in this particular lecture we will be trying to find out which of the following molecules show geometrical isomerism. So for example number 1, which is a alkylidene cycloalkene, okay, for that if we draw a line and consider there is a plane across this line, then we can see that the right hand half is equal to the left hand half. So GI is not possible. For the next molecule, again we can draw a line like this, and we can see for the carbon that I have drawn just now, the right hand half is not equal to the left hand half, but for the carbon below, which is this one, hydrogen is equal to this atom over here, which is also a hydrogen. So we will say no GI possible. For the other one, if we draw a line, then we can easily say that the right hand half is not equal to the left hand half, so GI is possible. For this molecule too, we will say right hand half is not equal to the left hand half, so GI possible. For the molecule number 5, for the carbon below, which is this one, right hand side is not equal to the left hand side, but if we consider carbon over here, the right hand side is equal to the left hand side, so no GI possible. The line across this plane, or should I say reverse, the plane lying on this particular line is dividing the molecule into two equal halves, so GI not possible. Now GI is possible when we have in allenes n equal to odd, that is the number of double bonds is odd. Now here, since this particular carbon has two hydrogen and also has two hydrogens, so here GI will not be possible. Had it been a case where along with hydrogen there was another group or atom at both the terminal carbons, then GI would have been possible. When the number of double bond is even, GI is not possible, so we will rule this out. Even OI will not be possible over here because this carbon has two hydrogen, okay. However, in this case, N is again even, so out here geometrical isomerism is not possible, but optical is possible. So we will say GI is not possible, but optical isomerism is possible. Again, this particular molecule, we can see the N is odd, but GI is not possible because the carbon at this end is having two hydrogens, so no GI. Here N is odd, so GI should be possible over here, and no OI possible. Now since we can see there is a chlorine and a hydrogen, and over here there is a chlorine and a hydrogen, so we can say this to be as a showing cis geometrical isomerism, okay. Again, N is over here odd, and now as you can see, Cl and this Cl are lying opposite to each other, so this is showing trans geometrical isomerism. In molecule number 13, this is again an allene in which the N is even, so GI should not be possible over here, but since there is a phenyl and there is a hydrogen, there is a hydrogen and there is a phenyl, so optical isomerism is possible over here, okay. So for this one and this one, GI is possible. Again, we can see over here in an Allen system, N over here is even. So obviously GI is not going to be possible over here. In the other system over here given as 15, but OI is possible, okay? So because CH3 is not equal to tertiary butyl group, okay, and hydrogen is not equal to chlorine. So OI should be possible over here for surely. Again, there is a ring and there is a double bond instead of having two double bonds. So over here also N, we will say it is even, okay, and so GI should not be possible over here, but surely OI is possible. So number 15 number molecule will be showing optical isomerism and not GI. Again over here, as we can see, number 16 molecule, over here there is a lone pair which can also be considered as a group, and this is basically an oxime, and since there is a ring and then there is a double bond, all right, so we will say GI not possible, but optical isomerism is going to be possible over here. Now again in question number 17, as we can see, again we have been given a semi-carbazone, okay. So if we consider this lone pair over here, so N is connected to two different groups and this carbon is connected to two different groups, and instead of two double bonds we have a cyclic ring and then a double bond. So this will be showing optical isomerism and no GI is possible. So GI we will say not possible, but optical isomerism is possible. Now in this particular ring system, which is basically a spirane, if this ring is horizontal then this will be vertical to the plane of the paper, okay, but since the groups over here attached to the terminal carbons are all equal, so no GI or OI possible, okay. Now over here, if the N is even, then again it is the optical isomerism that will be possible, and since over here at the terminal carbon we can see both the groups are different, so obviously it will show optical isomerism. Similarly, as we have studied in example 19, over here instead of two double bonds we have two rings, so N is again even, so this will be showing optical isomerism and no GI as such is possible. Okay, and again if we look for the molecule 21, then this particular system is obviously going to show geometrical isomerism, which is possible because instead of a NH we can have the CO over here, so that means there can be another molecule which I'm going to draw for you, in which we can say the NH groups are lying opposite to each other. Okay, and the CO groups are also lying opposite to each other. So if we consider that kind of an arrangement, so molecule number say 21 which was given is going to be cis, and using the same analogy we can say this is going to be the trans. Again, this tetraalkyl ammonium salt which is basically like a spirene. So instead of having two double bonds we are having two rings, so this is going to be showing optical isomerism and no GI is possible. Okay, again similarly in this particular system, that is 23, what we can have is that this is the molecule that will be showing geometrical isomerism. Okay, now again if you take question number 24 which is again a spirene, so this is horizontal, vertical, horizontal, so these two carbons are in plane now. Since hydrogen is lying on the same side as the other hydrogen on the other carbon, similar with the chlorine, so this will be defined as to be cis. So again, if we consider the pi electron cloud over here to be horizontal, the cyclic ring to be vertical to the pi electron cloud or lying at a 90-degree angle, then the other is going to be lying, pi electron cloud is going to be lying in plane with the first pi electron cloud. So over here we will say horizontal, vertical, horizontal. So these this hydrogen and hydrogen connected to the carbon are lying on the same side, and these are also lying on the same side. So this molecule obviously again will be showing GI, and this is again we will be calling as cis. You can also say instead of three double bonds we are having three rings. So n value over here 3. So whenever n is odd, it should show GI. Instead of having three double bonds, we are having a double bond. Then we are having a ring, and then we are having a double bond. So again here also the n value is 3, which is odd. Again we are having horizontal, vertical, horizontal. So n value is equal to 3. Okay, so this molecule should be showing GI, and this we will be calling as trans. So over here 26 and 25 are basically geometrical isomers to each other. Okay, I'm sorry, 26 and 24, these two molecules will be geometrical isomers to each other. Well, biphenyl is neither going to show GI or OI because there are no bulky groups joined here, okay, at these carbons. However, we can see bulky groups being joined. In this molecule 28, even though the rotation across this bond is restricted because of these bulky groups present on these carbons over here. Yeah, let me use another angle. these ones, but there will be a plane of symmetry bisecting this molecule into two equal halves. Okay, and for that reason there is no OI possible, even though the stereogenic area over here is n equal to 2, that is even. However, in case of 29, wherein this group is not equal to that group and that is not equal to that, okay, we will say there is no plane of symmetry, and because of the restricted rotation and n value being 2, it will be showing optical isomerism, but no GI is possible. Okay. Another similar case in which we are having two different groups, that is ethyl and tertiary butyl, and ethyl. So there is a restricted rotation over here in this molecule, and n value being 2, the molecule will be showing optical isomerism. Okay. Thanks for listening. Have a great day.